What is the water cycle? The water cycle is nature's remarkable recycling system, a continuous movement of water on, above, and below Earth's surface. This endless journey is powered by two fundamental forces: energy from the sun and gravity. Every drop of water on Earth participates in this cycle, transforming between liquid, vapor, and solid states as it travels through oceans, atmosphere, land, and living organisms. Water moves from the land to the sky and back to the land again. This cycle happens every day. The water cycle involves various processes like evaporation, transpiration, condensation, precipitation, collection, and runoff. Let's examine every detail in each of these processes as they are vital to sustaining all life on Earth, shaping our climate and weather, and continuously replenishing the planet's water supply. Let's start with evaporation. Evaporation is the crucial first step in the Earth's water cycle, transforming liquid water into an invisible gaseous state known as water vapor. This fundamental process is primarily driven by solar energy, which provides the heat necessary for water molecules to gain enough kinetic energy to break free from the liquid surface. The rate of evaporation is directly influenced by the temperature, with warmer conditions accelerating the process, making it a dynamic and ever-present force in our planet's climate system. The sun's immense heat energy is the primary catalyst, transforming vast amounts of liquid water into invisible water vapor. Covering approximately 71% of the Earth's surface, the oceans are by far the most significant source of atmospheric water vapor. They contribute to over 80% of the total moisture in the air, with billions of tons of water evaporating from their vast surfaces daily. This enormous volume of ocean-derived vapor plays a crucial role in the global weather patterns and climate regulation. Plants also play an important role in the water cycle process called transpiration. Plants are nature's silent architects, continuously releasing water vapor through microscopic pores primarily located on their leaves, called stomata. Beyond merely releasing water, transpiration performs several vital functions for plant life. It creates a continuous stream of water from the roots to the leaves, driven by the cohesion tension theory, which facilitates the efficient transport of essential nutrients and minerals absorbed from the soil. The volume of water released by plants can be astonishing. A single mature oak tree, for instance, can transpire hundreds of gallons of water into the atmosphere daily, particularly during warm growing seasons. While smaller plants release less, their collective impact across the vast vegetated areas is immense. Different plant types, from towering redwoods to expansive grasslands, contribute varying amounts, and this process is significantly influenced by environmental factors such as temperature, humidity, wind, and soil moisture levels. Transpiration imparts significantly to the atmospheric moisture, playing a critical role in the local and global weather patterns. The water vapor released rises into the atmosphere, condenses to form clouds, and eventually returns to Earth as precipitation. Because both evaporation from the surfaces and transpiration from plants release water vapor into the atmosphere, scientists often combine these two processes under the term evapotranspiration. Globally, transpiration is estimated to contribute around 10 to 15% of all atmospheric water vapor, with the majority coming from direct evaporation, primarily from oceans. As water vapor rises into the cooler upper atmosphere, it undergoes a fascinating transformation. The cooling air causes vapor molecules to slow down and cluster together, turning back into tiny liquid droplets. This process is called condensation, and it causes clouds to form. This transformation occurs when the air becomes saturated with the water vapor and it cools to its dew point temperature, the temperature at which air can no longer hold all of its water vapor. Below this point, the invisible gaseous vapor can no longer remain a gas and begins to convert into visible liquid water or ice crystals. Warm air carries water vapor upward into the atmosphere. This upward movement is primarily driven by convection currents, where warmer, less dense air, rich with evaporated water vapor, rises from the Earth's surface. As these buoyant warm air masses ascend, they encounter lower atmospheric pressure and begin to expand. The higher the altitude they reach, the colder the surrounding air becomes, setting the stage for the next critical phase of condensation. Billions of tiny droplets cluster together, creating visible clouds. When clouds become heavy with water droplets, the water falls back to Earth. This falling water is called precipitation. Precipitation can be in a form of rain, snow, sleet, or hail, depending on the temperature. Rain is a liquid water falling from the sky, formed when water vapor in clouds condenses, forms droplets that combine and grow until they become too heavy to stay suspended and then fall to Earth due to gravity. Snow forms when water vapor in clouds directly freezes into ice crystals, requiring the temperature to be at or below freezing from the cloud to the ground. These individual ice crystals, often hexagonal in shape, grow by collecting supercooled water droplets and colliding with other ice crystals. The intricate and unique patterns of snowflakes are influenced by the specific temperature and humidity conditions encountered as they fall through the cloud, creating the diverse forms we observe. Sleet forms when snowflakes fall through a layer of warm air that is above freezing and partially melts, then re-enter a deep layer of freezing air closer to the ground, refreezing into small, translucent ice pellets before reaching the surface. Hail, on the other hand, is produced in strong thunderstorms with powerful updrafts. Raindrops or partially melted ice crystals are carried upward into extremely cold regions of the cloud, where they freeze and grow by collecting supercooled water. They can be tossed up and down multiple times, adding layers of ice like an onion, until they become too heavy for the updraft and fall as solid chunks of ice, ranging from the size of a pea to golf ball size or even larger. The next process is collection and runoff. Once precipitation reaches Earth's surface, water takes multiple pathways back to the oceans, lakes, rivers, and streams. Rainwater flows over land, collecting in streams that merge into rivers, eventually reaching the ocean. Some water soaks through the soil into the underground layers, becoming groundwater stored in aquifers. Groundwater slowly moves through rock and soil, eventually seeping into rivers or directly into oceans over the course of months or years. Water returns to the ocean, ready to begin the cycle again through evaporation. Let's review the processes involved in the water cycle. These include evaporation, transpiration, condensation, precipitation, collection, and runoff. Comment below which step of the water cycle did you find most interesting. Thanks for watching and see you again in the next lesson.